Okay, first of all, thank you, Marcela, for the introduction. I don't see some of you because of the screens, but no, don't worry. And thank you to the Digital Design Research Unit and the University for the Hospitality. Elena, thank you very much. It's a pleasure and an honor to come back to university each time I have the opportunity, so I hope you enjoy the lecture as much as I will. The lecture today is Parametric Design Strategies. Before we start, I'd like to clarify one thing. I share a great passion for architecture. You can dim the lights, it's fine. As I'm sure, all of you do, otherwise you wouldn't be here today. So I'm going to try to convey that passion into the lecture. However, I wouldn't like to be misinterpreted. I love architecture. I have my own take on it, but I respect other takes with the same intensity. So why do I say this? Because in order to contextualize the lecture, we're going to talk about, I'm going to use modernism as a benchmark. So yes, I will dare to criticize the work of some of my heroes and probably your heroes as well. But it's not for the sake of criticizing it. Actually, it's basically to convey the message. So I hope you can forgive me for that, and you can contextualize whatever criticism or whatever, how can we take architecture forward. Obviously, these are masters we're talking about, but I think university is the right place to do these things. Having said this, we can start. So if we look for a definition of architecture, we can find one in one of the early modern manifestos. So Le Corbusier wrote towards an architecture in 1933, and there he states that architecture is the masterly, correct, and magnificent play of masses brought together in light. So next to the definition, you can see there's an illustration. I obviously inverted the colors, but this illustration is not innocent at all, and it's full of intention. It's a bit what we were talking before with the students, like when you want to convey a message, you really have to, nothing is left for chance. So Le Corbusier was very clever. And when he says that architecture is that a play of masses brought together in light, he chooses 5 Platonic solids, and this is what he draws. So he draws the light, he draws the shadows, but he also very clearly draws the outline, a very sharp outlines between these solids. So there's a very clear figure-ground relationship. So he does differentiate the figure against the background. For him, it's very clear what's architecture and what's not architecture. So whenever he builds one of his manifestos, like buildings, which would be Villa Savoie in Poissy, near Paris, which I'm sure you all know, it's 6 years after the book was published. And the villa raises itself over pilotis, over structure, so that then the garden goes underneath. So again, he's clearly defining what's architecture. Architecture is white, the grass is green. You can tell figure-ground relationship of mutual exclusion. Like, this is my intervention, and that's nature. And I put this artificial intervention against nature. It's like 20 years later, modernism and it's at its peak, and we see Mies van der Rohe. He builds the Farnsworth, again, built over 2 platforms. So nature can live its own life, he says. So again, it's very clear what's architecture, what's the intervention, figure-ground relationship. What happens if, there's nothing wrong with it, but you can tell that it's very clear the relationship they have between the intervention and the context. What happens when we go a bit to a wider scale? So we can go to Unité d'Habitation, Marseille, wider building, also dwellings, same principle. Over the structure, you have the nature, like a very modernist approach. And if we keep going to a bigger scale, things like this start to happen. So as you know, modernism is strongly linked to Fordism. So the Fordist society, named after Henry Ford, like the one that did the cars, it's a notion of modern economic and social system based on a standardized and industrialized form of mass production. So, obviously we should not forget, the task of the architects after the Second World War was to rebuild Europe. So in that context, we find this intervention of Ludwig Hilberseimer in Berlin. So we have a modern / Fordist, if you want, strategy, like this positivism attitude that is based on mass repetition. And so you define an optimized solution, and then you repeat it. The problem is that there's the risk that the city is not legible anymore. There's no character, no sense of place, and citizens get disoriented, like we can see in the perspective. So if we look at the intervention, I mean, like the whole lecture is going to be, I'm going to be repeating like the 3 key points. One would be the figure-ground relationship. The other one would be scale, and the other one is the design approach. From the figure-ground relationship, like we see the same relationship that Villa Savoye or Farnsworth House have. So it's a mutual exclusion. It's very clear where the intervention is. You have the intervention, you have the context. There's the sharp outline that we saw in Le Corbusier's definition of architecture. Scale, there was nothing wrong with the villas, but there seems to be a limit beyond which the repetition of a standard solution, it's not enough. And then the design approach, the site is understood like a blank slate. So tabula rasa, where a new order is imposed from the top down. So we have the figure-ground relationship, the scale, repetition, and then a top-down design approach. So how would parametricists or like parametric strategies would deal with these things? So the answer to these 3 key points, like from the figure-ground relationship point of view, the intervention is not a closed system of relationships. So the proposal absorbs, interprets, and incorporates information from the site. I will go later into these examples, but you can see how the intervention blends into the site until like there's a moment where you can't really tell where the intervention starts and where it ends. Similar to what you can see in like Cubist paintings from Picasso or Braque, where you have the figure and the background, but it's not clear where like the figure ends or what the background ends. From the scale point of view, in a way, as opposed to the Fordist logic, to the modernist logic of the repetition of a universal type or optimized solution, the strategy here is continuous differentiation. So it allows to hybridize different typologies, allowing to adapt them to the environment. So there's a balance between difference and repetition that allows us to create continuous gradients. And this is crucial because it will enable the architect to work across all different scales, maintaining the same logic, as we'll see like later with some examples. And last, so we've talked about the figure-ground relationship, the scale, and then the design strategy. So the final result here is not the end of a linear process imposed from the top. The design emerges from the different relationships that we find in dynamic fields. So here we have like a funny word like fields. What are fields for us? So Patrick Schumacher, like in the Venice Biennale in 2008, he basically read the Parametricist manifesto. And he said like modernism was founded on the concept of space, while parametricism differentiates fields. So fields are full as if filled with a fluid medium. To visualize this, we can think of liquid, where you drop a stone and then you can see the ripples, or we can think of like swarms in nature or flocks. Every time I mention this, it comes to my mind like first time I went to the Piazza Navona in Rome. If you go at dusk, sunset, like you see all these birds like dancing and flying, no? And it's amazing because you see thousands of birds, and every individual is different, but they all move at the same speed and they keep the same distance from each other. And the moment one moves or deviates, the whole system readapts itself and it balances itself. And you get these immensely complex forms, but these forms emerge from the behavior of individual agents. So it's not imposed from the top down. When you do tabula rasa and say, okay, I'm going to do my intervention, I wipe out everything, and now I put my order. No, the order emerges from the system. So I think that's like the best metaphor I can think of for a field, how fields work. So now, I mean, having introduced like this, like 3 key concepts, like figure-ground relationship, scale, and the design approach, and like what a field is, I think I'd like to take you to a journey through scales in order to see how this allows us to basically maintain the same logic through the different scales, and how like parametric tools or parametric strategies can help us to take like a bit further this relationship with the context and like with multiplicity and integrating heterogeneity into the project. So the 4 scales we're going to look at would be first territory, then we will go to the urban scale, then building, and then component. For territory, it's a density case study, and it's a project we did in 2007, I think. This was for an exhibition in the Tate Modern called Global Cities. And it was a speculation of how London could grow across the Thames to the east. So we basically mapped the 4 typologies that, basic typologies that we found in London, which would be the villa, like the block, the slab-shaped block, and a tower. And those we sort of translate into point, line, plane, and volume. So this would be like our like starting Platonic solids, if you want, like the cylinder, the prism, the cube, the sphere, these things. But instead of then populating intervention out of repetition, what we do is we blend them. We start finding all the intermediate situations that you can find. What happens if you put a bit of villa, a bit of tower, a bit of block, a bit of slab? There's an infinite number of possibilities that then arise. So you can then start generating fields when one condition dominates the others, and you can then start playing with density, start like, okay, what happens if the blocks lose the patio, or like what happens if we need to create a cluster of towers. These kind of situations start to emerge. But as you can see, we're not dealing with an optimized solution, or like we're actually blending them, mixing them. So what we need to do first, like, it's in order to get some order, is okay, we have a tool, how can we use it? We have these different typologies, let's start blending them, let's start pairing them. So here we pair, like, I don't know, tower with block, for example, and we can see how the tower becomes a block, but you never have like a pure tower or a pure block. There's always some sort of gradient, continuous differentiation across the system. And then all the different typologies in the middle that we could have not guessed or come up with. It would take you eternity to basically go through all these iterations. And this is why you basically set the limits of the tool. So these abstract field studies, basically what we're doing is developing the sensibility with the tool, knowing what the limits are, how much can we stretch the villa, how much can we stretch the slab block, like how much, what happens with the towers, do they have balconies, when do they lose them, can we actually pair like 2 completely opposite types, and new typologies, new orders start to emerge. If we were just repeating the typologies that we had, it would be very easy to guess, and you would have very clear outlines. Where does the villa neighborhood end? Where does the tower neighborhood end? While here, it's a gradient, like, and in the middle, a new sort of order emerges. It's not imposed from the top down. So we're not doing repetition. We're not imposing the order from the top down. But at the same time, there's this, we do have a very controlled system where if we want to do clusters of towers, if we want to increase the density, we know what we have to do. So once we've tried all these different possibilities, we take them on site, and okay, where is the intervention? And then we define the lines of the intervention, we have a site, and we have like lines of influence, where these things are going to happen and how. Before it was an abstract exercise, now they're actually going to affect each other. We were only pairing 2 types, now we're going to put the whole thing. So we create a responsive field so that we can actually do the same that we were doing with the villas, but with all the typologies. So how much in the system at a different scale, how much villa do I want to have, how much tower do I want to have, is the point, the line, the plane, and the volume that you see on the top right. So this system is always alive. Like you can always, a bit like the birds, when one moves, the whole system adapts. And that's the beauty of it in a way. So we can then populate our proposal, and we can see how, even though the extension of the site is it's amazing, and but we have defined the system, we have defined the rules, we have a range between which we can work, and then the order emerges depending on where do we want to have such typology, but it's never a repetition of that type. There's all these like intermediate stages that we wouldn't have been able to design that emerge from the system, and at the same time the system does not lose the coherence. So you can intervene in all these different individual buildings, but keeping the coherence in the system, like you see in swarms in nature, like you see in flocks. You still see the design intention, you still see the coherence of the full intervention. It's not just repetition and then it stops. It blends. You can't really tell where one neighborhood ends or the other. Like you get densities that come up, you get clusters, so it's these new type of relationships that appear that we wouldn't have been able to map otherwise. So again, this was a project that we did in 2007, and you may think, yeah, well, you need like, how many computers have you got at Saha? Like maybe you have like 200 computers just rendering this. How can I do this with my laptop? Well, I also want to destroy a bit that myth. These ideas are not new, and it's actually very, very, very simple to build a parametric model with no computers involved. This is not from the office. This is an exercise called Finding Form from Fraiotto and Bodorraz. And it's an abstract example, but it'll help us to understand what happens in like how we use this and how it helps us to take this abstract exercise to a different stage. So what they do here, they set out to map a city. They map a city into a ring. They divide it in equal number of points, and then the points are the houses or the places you go to in the city. And what you do is you connect each point to all the other points, only with a wool, like a thread of wool. So what you have in the figure on the left is basically Euclidean order, like top-down order where there's no hierarchy. Like you just have crossings, and that's it. And they say, okay, but the city is a bit more complex. How can we then, when you go from one place to another, usually there's a traffic jam or there's a detour. So how can we like charge the system with more information? How can this system absorb the information? So, okay, let's give an extra length to these threads of wool of 8%. That's how it can be 8, it can be 5, I mean, it could be anything, but they estimate that 8% is good enough. The moment you do have, you get the figure in the middle, which it's the same number of wools, it's the same connections, but a different kind of order starts to emerge. And then if you dip it into water, and the threads, they get sticky, and they tend to stick to each other. And then you start to see it's like an order that emerges. If you dip it another time, you will get another order. If you change the length of the wool threads, you will get another order. But if you think of a city, like the figure on the right is actually much more accurate to how a city works, and you have the hierarchy of the roads, you have free spaces in the center, like than the one on the left, where you have like order, like top-down approach, where you impose an order. So I wanted to introduce this before I went to the next sample, because the next sample is we're going to look at adaptability case studies at the urban scale. So we're jumping scale, but following the same logic, and it's master plan that we did in Singapore. This was 2009, so there were not so many computers involved. You can imagine like the power of computation you could have in 2001. But we arrived to what we call the soft grid concept. So it's a grid that adapts itself to the context, absorbing the information. So the different border conditions around the grid influence the grid. So in a way, this was done like almost manually, like even though it's described with, it's used with, we used computers and we rendered it and we modeled it, but it was based more on intuition, the kind of intuition you get from the model, from this form finding exercise from Bodorraz and Fraiotto, than like a very sophisticated tool. Like this is done like anyone can do it. So we also applied here for the first time an artificial landscape formation, but to the articulation of a whole urban quarter. So the advantages is, like I was saying before, it allows to integrate heterogeneity. So you have this pattern of streets that like softly sway, that allow to mediate all the different urban grids that are around the intervention, the site. So as you can guess, like the intervention is the magenta bit, but this soft grid basically adapts itself to the different conditions. So it also helps to produce a strong sense of identity. We can remember now the image I was showing from Ludwig Hilbert-Seimer. So it offers, like there's no repetition, so you have an original skyline that then engenders like a unique sense of place in a way, because you also generate all these different microenvironments. It's not repetition. Each place is different, but it's all part of a system, so the coherence of the intervention is maintained. So you have unity in difference. You have all these different blocks, but they are unified by the overall logic of the system. So it also allows to, there's flexibility, but there's no chaos. It's still a grid. But it's the morphology that we're proposing is not, it's more, I would say it's much more pliant or resilient to adapt itself, to like absorb the information. If you have like a pure block or a pure platonic solid, when you get to the edges, you don't know what to do with it because you have to chop it or you have to deform it. But here, the formation, it does no longer mean the breakdown of an order. It's the lawful inscription of information. So you're actually given information. It's not a bad thing to deform. And obviously, it helps you then to orient yourself. It's what you see like in the old towns of any city in reality. It's just like time. So this was the master plan. And obviously, like, again, I'd like to stress, it's not about the formal language, it's about the strategy. So then other architects came and they did their proposals, but it still all fits into like a coherent system where you have flexibility. It leaves enough flexibility, but the system it doesn't get broken if someone uses a different language or whatever. Another project would be, this one is in Istanbul. So I'm jumping through projects. I don't think the point of today's lecture is not to describe this project or the other. It's just to look at the strategies. So this is a master plan that we did in Istanbul in Turkey, 2006. So here, this is closer to the first example I showed. We have more computation, but we know we have all these ideas in the back of our heads. Like we've been working with the soft grid in Singapore, and it's like, how can we actually do these things? Like how can we take forward this exercise of Fraiotto and Bodoras? This is a master plan where we had to redevelop an abandoned industrial site. And again, we basically had very different border conditions that needed to be married, they needed to be connected. So what do? Well, we do the same that we saw in the form finding exercise from Bodoras and Fraiotto. We stitch. We know what we want to connect, we connect them, but then now through computation, we do simulate this dipping exercise of the wool thread into water, and then all these, we can give different properties to these connections, and then they start to coalesce, they start to, like, a hierarchy, an order starts to emerge. So this is the example I was showing in the beginning. The figure ground relationship, it's not a mutual exclusion. You have an intervention that absorbs the information and adapts itself. We can see how the grid that we see in the fourth image, it's almost an orthogonal grid, but then all the intuition we developed when we were doing the One North master plan in Singapore, the soft grid starts to adapt, to absorb the information from the context. So in an animation, like you can see it here, how the grid starts orthogonally, but then starts to like absorb information until you can't really tell. We don't have this sharp outline that tells what's the intervention or what's the context. So obviously you can then start to experiment not only with stitching or like connecting, but also with growth. So you can start like how much density do I want to have? And this is exactly the same exercise we were doing before, where we're actually just like developing a palette of responses, like a language, in order to then populate later the proposal. So we display with our platonic solids, but instead of repeating them, we just play with them and see what the range is, see what the limits of the tool are. When does the block stop becoming a block? Where does the patio have to disappear so that it's still meaningful? When does it become a tower? Can we fade the intervention so that then a public park or a public space appears? Can we create clusters of towers? Like, can we then pair them? Then when they're too close, does it become full volume? So these are all exercises that we do in order to then decide, okay, now we know what we can do, we know what the limits of the tool are, so we can intervene. We can just put the proposal, and then we start with the grid, but then the grid deforms, and then density starts to appear, and then there's a different morphology for whatever goes into the water, or like we have this sort of continuous differentiation I was talking about, where you're not repeating a typology. So we jump again in scale. We're already in the building scale, and here it's more about performativity. So what happens so we've looked at density, we've looked at adaptability, and now we're going to look at performativity. This is a project that we started in 2009. It's the King Abdullah Petroleum Studies and Research Center. We call it CAPSARC. It's in Riyadh in Saudi Arabia, and it's on site now. So here, the problem was very different. What do you do when you're faced with a site that is 500,000 square meters, when your building is going to be 60,000 square meters, and this is in the middle of a desert? There's no context. There's no information to absorb. So if you remember, like in all the previous examples, there was a very specific border condition that you would have to connect, or however, here we need to come up with that order, with that condition from scratch. So we chose to work with an hexagonal grid system. Why? Well, basically it increases the connectivity because you have 6 instead of 4 neighboring cells. So you have a higher density of communication, which for a research center, it's desirable. Also, like 120 degrees instead of 90 degrees, the ease of movement improves. And also there's an increased compactness to the cluster of buildings, because this is building scale, but it's actually a cluster of buildings. So it implies better energy preservation, which, considering that the building is in the middle of a desert, it's an important thing. So we developed this idea of an hexagonal grid with patios, which is not a closed system again. These can be adapted, extended. So in the future, if there's an extension, you just plug into the system, and then it can grow. It's not a closed system. We can see how we use it to articulate the buildings, but we also use it to articulate the spaces between them, or even the landscape. So again, we set about to see what the limits of the tool are, and we start. You can see very clumsy examples. We don't control yet because we're trying everything at once. So it's like, no, wait, we need to set up a system, we need to set up constraints, because those constraints are going to be the information that is going to then allow later the order to emerge. So we set up the system first in plan, and we say, let's work with the hexagons and with the patios. What happens if the patio is small and in the center? What happens if we have one on the bottom? What happens if we have 2 patios where we have maybe circulation and the patio and then the program around it? So we map our platonic solids, our like ideal situations, if you want. But then instead of repeating them, instead of repetition, what we do is we blend them. We do what we did before at all the other scales. So we start trying to find out what are all the intermediate situations, like all these infinite possibilities that can help us later to articulate the project. This is only in plan. We're just like trying to see what the relationship with the patios are, how the hexagonal system can get deformed, like how can this lead to, it's an abstract exercise. But it allows us to develop the palette of responses. But then we've only worked in plan so far. But then you realize I was saying that there's no information because it's in the middle of the desert. Well, it's really not entirely true. In fact, I think the weather, the climatic conditions such as the orientation, the wind, is going to help us to differentiate this field that it was only in plan, but now in section. So we know that we can open these cells to get the cooling winds into the patios, and then the buildings that we have can grow a hood to protect themselves from solar radiation, and then complexity starts to emerge. Then the system of patios we were thinking about, where we had circulation and we had program, it starts to make more sense. So the iterations that we go through start to show much more order, much more control. So now the section starts to develop, and we do exactly the same. Same exercise we had done in plan, so this continuous differentiation, we apply it to the section. What happens if the patio grows? What happens if it goes to the back? What happens if we turn it into a terrace and there's no patio at all? So all these bits, there are different steps that will allow us to then define the different typologies, which will then become the project. So we then start to marry these typologies with the program. So we developed the light cone, we developed the courtyard, roof terrace, indoor garden, and then we put them all together into the section. So in the end, it allows us to make sense of a system. So now we're also taking into account, we generated an order from scratch. It has emerged like from our system, but we also have all these strategies that will help us to enlarge the proposal if we have to, and to generate the landscape. So this is a model. This is what rendering looked like. So as you can see, there's nothing. There was no information whatsoever, a couple of roads. And these are the buildings for the skeptic ones that say, yeah, this can never be built. Sometimes it does. And this is how we were visualizing the patios, and we can see how these patios start to emerge, how the pergolas are built. And like it's actually, this cluster of building is starting to take shape. We can see it here. And hopefully it'll be built, I think, in a year time or so. There are a couple of buildings that are done, but in a year or 2 years, the full complex will be built. So we've looked at building scale. Let's jump to the component scale. When we talk about component, this is the last scale we're going to talk about. We have either performative structure or facade strategies. Before I show another project, I would like to stress that these ideas are not new. In the same way we saw the model from Frei Otto and Bodo Ras, like Gaudi was already like building parametric models like 100 and something years ago. So he was very clever, and he knew that if he he just generated a system of weights hanging from the ceiling, and he knew that like the proportion, like the shape that he would get, the catenary was the ideal shape to then hold the Sagrada Familia building. So this is a parametric model. If you modify one of the weights, it has a knock-on effect in the model. Like it's a super complex model where there has no computation, no computers, like nothing like that is involved here, and it's still very complex. So it's not so much about the tool, or it's about the strategy. It's about like how you look at the problem, how you face it. So what would be the top-down approach for a structure? If you talk to an engineer, and they're going to take you, well, if your building is roughly 100 meters, you probably want to have a framework structure. If your building is around 300 meters, you then want to go to an endoskeleton with all the different variations. And if you go beyond 400, you need an exoskeleton. So, but this is equivalent to these Platonic solids, this definition of architecture, like very stiff. Excuse me. So could we get the best of each structural typology and apply it only when required? The diagram would look something like this. So you have an exoskeleton at the base, and then an endoskeleton in the center, and then where the building doesn't need so much structure, you just have framework structure. So this is that would be a bottom-up approach, where like the order emerges. It's a diagram where the order is not imposed from the top down. This is what we tried to do in a competition. This was in Kuala Lumpur, 2009. And again, basically we arrived to an exoskeleton that actually reacts to the program on the one side and also to the structure. So you get more density when you need it, you get more depth when you need it, depending on the orientation. And then as it goes up, it fades away. But it fades away in a way that you can't tell what's the figure in the background. So it's a continuous gradient, it's a continuous differentiation. So even though we map different programs, which are the five like lighter cells that we see in the elevation. One is a car park, the other one was hotel, residential, offices. It was a mixed-use tower. We map them, but what we do is blend them. we don't repeat them and then have like a line, a frontier, and then put another typology. No, we blend them. So you can see here, this would be like the generic grid that then gradually gets deformed until it finds its balanced position where you actually have the exoskeleton, so more density of a diagrid below, and then it fades away as it goes up. So the unwrapped elevation would look something like this. You can't really tell where one starts and when the other one ends. So it's this figure ground relationship of inclusion, and instead of repetition, we have this gradient, we have a continuous differentiation, and the order emerges from the bottom up. I'm not drawing each corner to see. I generate a system to allow the order to emerge, and then I can do as many iterations as I want until I get what I need. Another example would be a competition we did in Madrid, Spain. This is the civil court building, but it was part of a master plan. It was called the City of Justice. This is like now the situation has been inverted. Like there's another architect that generates the master plan, and the idea they came up with is that all these different courts, in this case, like we had to deal with one of them, would generate the City of Justice, and the massing were going to be cylinders. So we're given a cylinder, we're given the massing to work with, and then we start, okay, how can we play with this? How can we charge this with information? How can we differentiate it? Again, you look at the program, you look at the orientation, generate the patio. We start, so what do we want to open to? What do we want? Do we need to protect ourselves from the south, from the west? How can we then generate an envelope that reacts? Because we knew it had to be a cylinder, so how can it react to the program inside and to the orientation? We can see there like all the four elevations, north, south, east, and west. In the north is obviously more open, but we can see in the other ones the gradient. So it's a full system. So there's no, like the different program, like there's this continuous differentiation where the program blends. You don't know where one starts, the other ends. Sometimes you need to look out, sometimes you don't, sometimes you need privacy, sometimes you need sun. So this would be the section. How do we get that envelope to work? Again, we do the same thing. We start in abstract. We develop our ideal scenarios where the panel would be closed or it would be open, or you protect yourself from the east, from the west, depending if it's north, south, or if it has a program that needs to be exposed or not. So then we generate a field that is responsive, and then we start blending all these different conditions. And we start experimenting with the tool, seeing what the limits are, and you know, allowing these orders to emerge. So this is in abstract, but then obviously we take it to the building, we take it to the envelope, and just like we've seen in other cases, like once the strategy and the palette of responses is developed, we don't know what the result's going to be. Like this is not an order imposed from the top down. We get a system that is responsive, and we can play with it. So again, we're not doing the repetition, we have continuous differentiation, and you can't really tell. So the figure ground relationship, it's of like affection, or like it's not mutual exclusion. So I did mention in the beginning of the lecture that this lecture was not to trigger a formal discussion, although I know that the projects I've shown are formally charged. But I can't help to see beauty in these systems, similar to the one I find in nature. So like this image of the starlings in Piazza Navona, like flocks or schools of fish, keeps coming to my mind. And when I look at these orders, I look at these systems, even though we've gone through all different scales, like this image also reminds me of the very first one, of the Thames Gateway, where we were studying the density. So in fact, I mean, we've been applying the same logic through the different scales, which is what these tools or these strategies allow us to do. So I don't know, like, could we articulate the complexity of our contemporary built environment like through bottom-up processes? In the same way we see articulation in nature through endless shapes, like product of evolution. I don't know, I mean, I don't have an answer for the question, but I suspect that as architects, we sometimes limit ourselves, taking too many things for granted, and with the current tools available, I think the possibilities are infinite. So since I started the lecture like quoting Le Corbusier, I'd like to finish it like quoting a poet, William Blake, precisely because of this notion of infinite, all these possibilities that we have now. So William Blake in The Marriage of Heaven and Hell said, like, if the doors of perception were to be cleansed, everything would appear to man as it is, infinite. Thank you very much.